Hello all, welcome back to my YouTube channel all about VLSI. Hope you are all doing good. So with this video we are going to start with the system verilog verification of our RAM. Okay, so we are going to first design our RAM, okay, using verilog, and we are going to develop the test bench using the system verilog. We are going to develop the system verilog test bench, and we are going to test our design, which is nothing but our RAM. So in this video, so basically I'm going to describe how to develop your test bench. Okay, so what how the test bench of system verilog looks, and what are the components which are present in your system verilog, okay, test bench. So in system verilog test bench we have different components. So before starting with this particular video, if you haven't uh, watched our videos regarding system verilog, or if you are new to system verilog, or if you don't know the system verilog language, please go and watch the system verilog videos which are already available on our channel. Okay, yes. So let's say this is our design. So this is our design, which is nothing but our RAM. Okay, so this is our design, which is nothing but our RAM. So this we are going to test. So this design or our RAM we are going to test with help of our system verilog test bench. So this design is connected to our system verilog test bench. So this is our SV test bench. I will draw it as a box. This is our SV test bench. So we are going to connect our SV test bench with our design with the help of our interface. Okay, with the help of interface, we are going to connect our design and test bench. So with the help of interface, we are going to connect our design and test bench. So this is our design. This is our design, and this is our test bench. So our RAM has two type of control signals. One is write control signals. One is write control signals, and other signals as read control signals. So we have two type of signal, two type or two sets of signals. One is write control signals and read control signals. In write control signals, we have uh, write underscore write enable, and we have write address. Okay, and here we have read enable and read address. So on the right side, we have write control signals as write enable and write address, and on the read side, we have read enable and read address, and we have data in and data out, and we have common signals, global signals as clock and reset are our signals. So clock, reset, data in, data out, write enable, write address, read enable, read address, data in, data out, clock and reset. So these are the signals which are associated with our RAM. Okay, so we will consider our dual port RAM. So regarding the dual port RAM, please once revise about the dual port RAM. What is mean by dual port RAM? What is mean by single port RAM? Okay, everything, and the size of the data, everything we will discuss later. What is the size of the data? What is how many locations should we have? Okay, that also we will discuss later in our sessions. Okay, so just we are considering the signals. Okay, we have different type of signals: write enable, write address, read enable, read address, and data in, data out, clock and reset. Okay, now, so in this particular test bench structure, the top for this test bench is our test module. So we have one component which is known as test, and this test is being connected to another component which is known as generator, and this generator is again connected to two components which is known as write driver and read driver, write driver and read driver. So since this particular RAM has two type of signals, one is write control signals, and another is read control signals. That's why we are going to consider these two components, write driver and read driver. So if a design has only one type of signals, we don't have any subsets, then we will take only one driver. Since this particular since this particular design has two subsets, two different subsets of control signals, so we are taking two components. One is write driver and another is read driver. So this interface signal which we are connecting from write driver to the design is known as write interface signal. Okay, this is interface and this is write interface. Write interface. And here on the right hand side, read driver and the design are being connected with the interface signal, and this interface is known as read interface. We are going to write only one interface file, but we are going to instantiate two handles. One is write interface handle and another is read interface handle. The interface file is same. The interface file is one only, but we are going to have two instances of our interface file. One instance name is known as write interface and another instance name is known as read interface. And we have another components which is known as write monitor. Write monitor and read monitor. Read monitor. Okay, so one is known as write monitor and another is known as read monitor, and there is a connection from the write interface signal to the write driver and write interface signal to the write monitor. Okay, and there is a connection between read driver to the read interface signal and read interface signal to the read monitor. Okay, now, and we have one more component which is known as reference model. Reference model, and we have one more component which is known as scoreboard. So this scoreboard is connected to our read monitor and it is being connected to this reference model, and this reference model is being connected to our write monitor, and all the components are instantiated inside another module which is known as environment. Okay, so this environment class will consist of the generator class, reference model class, scoreboard class, write monitor, write driver, write monitor, read driver. So basically the hierarchy is test class. So the hierarchy is nothing, it will look like this. So the top module will consist of our test class and DUT class. That is our DUT code. That is our RAM code. That is which is written inside module. Okay, our test and DUT are being connected with each other inside the top module. Our test and DUT are being connected inside that module which is known as top module. So this top module will also will have one more file which is known as interface instance. Okay, the interface instance creation will be done in the top module, and this interface handle, INF interface handle, will be passed from the top module to the DOT and to the test. Okay, from the top module only we are going to create the handle for the interface. We are going to create the interface instance, and this instance is going to be passed to the DOT and the test from the top module. Now, so this test will consist of environment, and this environment will consist of generator, and this generator is again subdivided into write driver, write monitor, read driver, read monitor, read monitor, read driver and read monitor, and we have reference model and scoreboard. So this is the hierarchy, simple hierarchy. Okay, and we have one more file which is known as transaction file. We have one more file which is known as transaction file, which is also written inside a class, and this file is not inside, it is not involved in the test bench hierarchy. It is a completely different file. This file is being used by the generator file and all other files. Okay, I will show you in detail how this file is being used by our different components. Okay, so this is the hierarchy of our system Verilog test bench. So this is what we are going to develop, and this is with the help of this we are going to test our design, which is our RAM. Okay, now, so as we know, so we will start with our basic drivers, or we will start with our generator model. What is meant by generator, everything. Now, so first one is generator. So this class basically will generate all the stimulus. So this class will basically generate the stimulus which is needed to drive our DUT, which is needed to drive the DUT. So this generator will drive the stimulus, will generate the stimulus which is used to drive the DUT. Now, the stimulus is declared in a class which is known as transaction. So there is a class I have told you, right? So we have a class which is known as transaction class. We have a class which is known as transaction class. So inside this transaction class, all our variables will be declared as rand. So all the variables will be declared with the keyword rand. Not all the variables. The variables such as write enable, read enable, write address, read address, and we have data in. So these signals will be declared with the keyword rand. So these variables will be declared as rand in which class? In the transaction class. And the data out is just declared as a logic. Okay, it is declared as logic data type. And the remaining signals, write enable, read enable, write address, read address, data in, will be declared as rand. And the width of write address, read address, data in is according to your design specification. So whatever your design is, so accordingly we can give the specification or we can give the size. It's not a matter. Okay, for now we are going to focus on what are the signals, what is happening. Okay, so these signals are declared as rand. Okay, so what is meant by rand, what is meant by randomization, everything we have discussed in our previous sessions when we are discussing about system Verilog. Okay, so these signals, write enable, read enable, write address, read address, data in, as are declared with the keyword rand in our transaction file. This keyword, these particular variables are declared with the keyword rand in our transaction file. Now this transaction class handle, so this class handle is used in our generator class. So when we are developing our generator class code, we will use our transaction class handle. We will declare our transaction class handle inside our generator class. We will use the transaction class handle inside our generator class. How to declare the transaction class handle? The syntax already we know. Class name, transaction, and some handle name, let's say t underscore h. So using this t underscore h, this handle, we are going to create the object for the transaction class inside the generator class. Inside the generator class, we are going to have the transaction class handle, and we are going to create the object for this transaction class. And after creating the object for this transaction class, we are going to randomize the variables which are being declared in the transaction class. The variables which are being declared in the transaction class with the keyword rand, so these variables will be randomized with the help of this object which is being declared in the generator class using the keyword t underscore h dot randomize. T underscore h dot randomize. So what is going to happen? The variables which have been declared inside the transaction class will be randomized, and those variables, so this t underscore h object will have all the values. Okay, it will have random values of write enable, random value of read enable, random value of write data, random value of read data, and random value of data in. And there will be no randomization performed on the data out, so the default value of data out will be present, and it will, and t underscore h is an object now. since we have created the handle for this object t underscore h inside the generator class. So we have random values for these variables and we don't have any random value of data out, so it will be in default unknown. Okay, since we have declared it with logic data type, if you declare it with any other data type, according to the data type the value will be decided. Okay, now inside the generator class we have created the handle of our transaction class, and we have created the handle for our class, we have created the object for our transaction class, and we have randomized, we have performed randomization using the transaction class handle, and we have created the object. Now, this generator class, as we have discussed already, is going to provide the stimulus which is being going to drive the design. So this generator class now has the object t underscore h. So this generator class has the object t underscore h. So this object will be passed to write driver and read driver using mailbox. So using the generator class, we are going to send whole object. We are not going to send variables one by one, but we are going to send the whole object t underscore h to our write driver and our read driver using mailbox. Okay, now what happens next? So after write driver and read driver receive, after they received this t underscore h object, after this t underscore h object is being received to our write driver. First let us try to understand this write driver. So after write driver receives this t underscore h object from the generator, what it is going to do? So this write driver is going to have the interface instance, right? So this write driver, what it will do, it will take one by one. Let's say suppose write driver, it is going to, let's say on the left hand side we have interface instances. This is our interface. And on the right hand side we have the object. Okay, let's say our interface instance name is inf. So inf dot read, this is write driver, right? So write underscore enable is equal to our transaction object name, which is our transaction object is being given to our write driver from our generator. Okay, so object name, instance name, let's say this object name is t underscore h. So t underscore h dot write underscore enable. So what we are doing basically, we are extracting one by one variable from this object. We are accessing one by one variable. We have write enable, write address, write data, all the write signals we are extracting from this object t underscore with the help of this handle name t underscore h, and we are giving it to the interface. We are giving it to the interface inf dot write underscore enable. We are accessing the properties which are present inside our interface with the help of this interface handle. Okay, so we have declared our interface file also. We will have an interface file. So in this interface file, all the properties will be declared here, like write enable, write address, write data. So all these properties will be present here. What we are doing basically, we are assigning the values of write enable to the from the object to the interface handle. Now, so like this, we are accessing one by one. That is, we are converting the transaction into pin level. So the write driver will access one by one property from the transaction object, and it will convert it into pin level transactions, and it will give to the design port by port with the help of our interface. So the generator is passing all the variables as an object t underscore h, and this object is being opened by our driver, and it is going to access one by one, and it is going to give it to the design one by one. All the write enable, write data, write address, write driver is going to give to our design. And similarly, read driver is going to do the same thing. Okay, read driver is also going to do the same thing. So read driver is also going to get the t underscore h object. So it is going to access each and every read control signal which is associated with the design. So it is going to access it with the handle t underscore h, and it is going to give it to the interface. Okay, so the interface, from the interface it is going to give it to the design. All the read control signals it is going to the give it to the design in the pin level. Okay, we are getting it in the object level, and we are converting the drivers are converting them into the pin levels. And so this is the role of your drivers, write driver and read driver. Write driver is basically passing your write control signals pin by pin to the design, and read driver are being passing the read control signals pin by pin, which have been received to them in the object file. Now, write monitor is going to monitor what are all the control signals or the data signals which write driver is being passing. Write driver, which is so the write monitor is going to monitor what are all the signals which the write driver is being passing. So the write monitor will monitor. So the name itself indicates the write monitor is going to the write monitor is going to 1 minute. So the write monitor is going to monitor the signals what the write driver is being providing. It's like a monitor of a class. Monitor of a class, what you will do, you will basically monitor what everyone is doing. So write monitor is going to monitor what are all the signals write driver is being passing. So that signals will be captured using the write monitor. Similarly, read monitor is going to capture what the read driver is being passing, as well as read monitor will also capture the data out signal from the design. So the data out signals or the outputs of the design will be captured by the read monitor, as well as read monitor is going to capture what are all the signals which the read driver is being providing to our design. So that is the role of your write monitor and read monitor. Now the read monitor also have the signals which are being passed by the read driver as well as the design outputs, whereas write monitor only have the signals which are being sent by our write driver to the design. These are being monitored. So the write monitor is going to give these signals which have been captured from the write driver, and it is going to give it to the reference model. So the write monitor is going to give them it to the reference model. So basically, 1 minute. So basically, this reference model is like mirror of your design, or it's like a replica of your design. The reference model will also work exactly as your design. Okay, so the reference model is also going to work as your design. How the design behaves if you give write enable signal, or how the design behaves if you provide write address signal. Similarly, the reference model is also going to work. If we give write enable signal, and what if we give write address signal, and what if we give data in signal. So if we provide write address is equal to 1 and data in is equal to 10 and write enable is equal to 1, then this reference model is also going to work exactly as your how the design is going to work. Okay, and it is going to provide you a data out. The reference model is going to provide you some data according to the enable signals or the inputs which you have provided to the reference model. So according to that, it is going to provide an output signal which is known as a data. So this data is given to a another component which is known as scoreboard. With the help of mailbox only, we are going to give it to the scoreboard. Okay, and from the read side, the read monitor is going to give all the signals to the scoreboard, all the read enable signals and data out signals. So in the scoreboard, the comparison will be compared. So the comparison will be performed. So the reference model output and the design output which is being given via the read monitor. So these two outputs will be compared in the scoreboard, and the scoreboard is going to tell whether your expected output and the design output are matching or not. If it is matching, then your design is working correctly. If it is not matching, then there is some error in your design. So this is the simple working of your SystemVerilog Testbench and all other components. Okay, so this is the working of your SystemVerilog Testbench and SystemVerilog components. I hope you have got a clear idea about I hope you have got a brief idea about how this particular components work. We will discuss them in detail when we are discussing the coding everything. Okay, yes, and also we are going to perform the functional coverage for this particular design. Okay, yes, so that's all for this session. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you. So if you have any doubts or queries, you can just ping me in the comment section. I will try to answer them. Okay, thank you.